right, so this is going to be a quick video, just going over what we were discussing in the meetup. So we were looking at special product patterns for polynomials. So what's going on here is that as you keep multiplying polynomials together, people have noticed that there are patterns that pop up. So for example, if you're doing a pattern that looks like this, of a question that looks like this, it's the same factors, like x pops up, 3's pop up, but with different signs, your solution is going to end up looking like this. So this is basically showing you like shortcuts of answering these types of questions without going over foiling or any of that or any of those steps. So let's look at the first one right over here. This one, I have 4n, and then I have a 5, but all they differ in is just their signs. So this one matches the first pattern right over here. So if I just follow that pattern, I'm just going to rewrite it up here. Plus b, a minus b is equal to a squared minus b squared. My 4n will be my a, and my 5 will be a b, will be the b, or the second term. So what's going to happen is, without me going over FOIL, I'm just going to replace everything. Instead of writing a, I will write 4n squared. And instead of writing b, I'm going to write 5 squared. Right? So now it's all about simplifying. So this one, 5 to the second power, it's the same as saying 5 times 5. So that will give you 25. So that one I already simplified. Now, when you have something that looks like this, where it's a coefficient, a variable, and they're being squared, you're just distributing that exponent to both of them. So it'll look like 4 squared n squared. And over here, we can simplify this because 4 squared is the same as 4 times 4, and that will give you 16. So this will become 16n squared. That's what we're going to put right over here. So that's the answer for this problem. Right? So notice how I just saved time. I was just using that format, and then we're good. All right, so let's look at the second problem. This one, I have 9y minus 2 to the second power. This matches this form right over here. So let me just rewrite them. So for A, I'm going to use my first term, which is 9y. And for B, I'm just going to use 2. I'm not going to use negative 2. It's just a plain 2. All right, so that's, a lot of us could get confused with that. So now that I assigned my A and B, my first and second term, I can now substitute. So instead of writing A squared, I'm going to write 9y squared. Over here, I have 2 times the first term times the second term. So 2 times 9y times 2. And then I have b to the second. So the second term, 2. Notice again, I'm not using a negative 2. It's just the positive, plain 2. I'm using that 2 squared. Now I need to go ahead and simplify. 9y to the second power, same idea. You want to distribute your exponent. This will give you 9 squared, y squared. And 9 squared, that's the same as saying what's 9 times 9, which we know as 81. So this will be 81y squared. So that's how we're going to replace this one. Now, right over here, okay, so we notice how we have a couple of coefficients, the 2, the negative 2, the 9, the 2. I'm just going to multiply those out, and I'm going to leave y alone. So this will just look like 2 times 2 times 9. You can do it any other order. Multiplication, it's commutative. It doesn't matter the way you It's a commutative and associative. It doesn't matter how you group things or how you wrote them, they'll still give you the same answer. So you can do -2 times 2, that's -4 times 9, and then -4 times 9, that's -36. So right over here, I'm going to write -36y, all right? Now let's look over here, 2 squared. Well, 2 squared, it's the same as 2 times 2, which is 4. So now we have a positive 4. And this will be my answer for this question. Okay. All right. So again, you could expand it. You could write a minus b times a minus b, and then you can just do the whole FOIL thing. But this is just telling you that this is the basic pattern it's going to follow, and it saves you some time. Now let's look at a third question. This one is a lot similar to this. This one's a lot similar to this form right over here. So let me just rewrite that. We have a minus b to the third power cubed, a cubed, 3a squared b plus 3ab squared minus b cubed. Okay, so that's the format. And with this one, they're trying to trick you here because A and B are over here. But when we're talking about A and B, we're talking about the first term and the second term, right? The first and the second term. So AB, that's going to be my first term. I'm going to call it A. And 4, that's going to be my second term. I'm going to call that B. And remember, it's just the plain B. It isn't um, it's just a plain 4. Okay, hold on a sec. Actually, oh, this one was a 4. So be mindful of these signs. It's easier to make mistakes like what I just did over here. So notice how I have a plus sign, right? So this form would be a lot similar to this one right over here, that first one, because it's doing A plus B. So I'm not gonna, none of these will be negative. I'm just changing them all to being positive. All right, so that's just a little change. Now I can go ahead and replace everything. So instead of writing A, I'm going to write my first term, which is AB cubed. Instead of writing A over here, it's the same thing, AB squared. B will be 4. So this means my first term, my second term. 3AB, this is AB times 4 to the second power, and this one's going to be plus 4 to the third power. Okay, so that's everything substituted. Now let's go ahead and simplify. AB to the third power cubed. Again, you're distributing the exponents. You're going to get A cubed, B cubed. This one, I'm going to have to distribute, but between the coefficients, I can go ahead and multiply them. So 4 times 3, that gives you 12. And if I do AB to the second power, again, distributing them, you're going to get A squared, B squared. Okay, now that's done. So let's look right over here. So you notice how I have a 3, but I have a 4 squared. That's the one you're going to multiply or combine together. So I'm going to solve the exponent first. 4 squared, again, same as 4 times 4. That gives you 16. So you're doing 3 times 16, which is 48. This is going to be a positive 48AB. Okay, and now we have 4 to the third power. 4 to the third power, that's the same as 4 times 4 times 4, and that gives you 68. No, that gives you 64. So this one will be positive 64. And then here, everything is simplified. I just had my answer. I didn't need to go do foiling and distributing all that. I just kept it like this, and we are set. So